Welcome to Operations Management. This lecture is about inventory management, and the second part will be covered in this lecture. The second topic of this lecture is economic order quantity model. This has been long been used and famous in business. To discuss economic order quantity, we need to understand a few things. First, order cost. When a business orders material, there is a cost associated with the process. The cost is made up to two components, a fixed cost and a variable cost. The fixed cost remains the same for any order that is placed by the business to a vendor. This type of fixed cost will include the cost of a company's facilities and the maintenance cost of the computer system used to process purchase orders. This cost will remain the same if 1 or 1,000 purchase orders are made. The other components of order cost include the variable cost. These costs will vary depending on the number of purchase orders that are processed. The variable cost can be significant and includes the cost of preparing a purchase requisition, the cost of creating the purchase order, the cost of reviewing inventory levels, the cost involved in receiving and checking items as they are received from the vendor, and the cost incurred in preparing and processing the payments made to the vendor when the invoice is received. To conceptually understand inventory cost, let us assume that the variable cost consists of holding cost and setup cost only. Setup cost or order costs are often overlooked by companies as they perceive the actions of employees, such as checking inventory or testing the quality of incoming materials, as a part of an employee's normal function. However, when circulating the cost of ordering items, it is often a surprise to companies that when they find out how much it actually costs to have an item of material purchased and available at their warehouse. Companies often forget that it costs far more than just to create 10 orders for 5 items each from a vendor than one order of 50. In this model, it can be calculated as D over Q times S. That's the setup cost. Here D is annual demand, and Q is quantity of inventory, and S is setup cost. Another part of cost stems from holding cost. Carrying cost is the cost associated with insurance, handling, obsolescence, transportation, and rental costs. The formula to calculate the cost is Q over 2 times H. Notice that the cost increases in proportion to the quantity of inventory. The total cost of inventory is made up of two costs, carrying cost and order cost, or handling cost or setup cost. So the total cost will be the sum of these two costs. And at a certain point, there is an optimum size of order when the total costs are at their very minimum. And that is here in this case, this dotted line, and here is the lowest point, optimal point. When a business is looking at their overall cost, they should examine the carrying cost of holding inventory against the cost of ordering material from vendors. It is clear that order costs are very high if a small number of items are ordered, while carrying costs are much lower when the inventory in the warehouse is very low. After that point, usually when there is no more benefits gained in larger orders due to the fixed cost of purchasing, the carrying cost of additional inventory continues to rise, forcing the total cost of inventory ever higher. That point is called economic order quantity. So this point where handling costs and setup costs are meeting together, intersecting together, that's the point where the lowest total inventory cost occurs. To find the economic order quantity, what should you do? Notice that EOQ is the point where setup costs and handling costs intersect. Therefore, you can find the point by setting the cost equal to each other and solving for Q. Therefore, let us set D over Q times S equals Q over 2 times H. And if you solve for Q, then it's going to be Q squared equals 2ds over H. And Q star will be square root of 2 times D times S over H. And here we know that Q is number of pieces per order, and D is annual demand in units for the inventory item. S is setup or ordering cost for each order, as H is holding or carrying cost per unit per year. Here is a simple example of a EOQ. Say you have annual demand of 1,000 and the setup cost $10 per order and handling costs of 50 cents per unit per year. Then you can put them into this EOQ formula. Then you will find that the economic order quantity at a time will be 200 units. Now, once you find EOQ, you are ready to find the expected number of orders too. Expected number of orders can be defined as demand over quantity, D over Q star. So simply put 1,000 here and divide it by Q star, which we found 200. So optimal number of order per year will be 5 orders per year. After doing that, you can also find N. After finding N, you can find the T. T is expected time between orders. So when you are ordering 5 times per year, what does that mean? You have 12 months per year. So you can divide by 12 months by 5 times, then it's going to be 2.5. So that's 2.5 months. Every 2.5 months you are going to order that. Or you can convert that to number of working days. Number of working days differ depending on the circumstance of each company, and you can include that working days. Say typically it's 250 days, so we want to put 250 days into number of working days per year and divide by 5, 5 orders per year. Then we find that every 50 days we should order. Finally, the total cost of inventory management can be now easily calculated now that you found the EOQ and other things. You just plug the number into total cost formula, which is TC equals D over Q times S plus Q over 2 times H. So include or plug these numbers into this formula, and you will find that the total inventory cost is $100. So this is fictitious case, so that's why it's just so low. However, in real business cases, it will be different.